The demand equation for a certain brand of headphones is given by 100x squared plus 9p squared equals 3,904. X is the number in thousands of headphones. So my first unit, number in thousands. First thing I can write down is I have an X. And the units on that is thousands. So X thousand headphones in this case. So under there, I'm going to have an X equals. And with the derivative of X with respect to time, I'm going to have a dx dt. And this is all in thousands. So you want to remember that when we fill out these answers. So X is a number of 1,000 and demanded each week given the price P in dollars. So my next one I'm given as price is dollars that these headphones cost. And I'm also given that the demand is for each week. So T is in weeks. So I'm going to have a P equals, and that unit on that is going to be dollars. And then dp dt is going to be dollars per week. Because dollars is a unit with P and T is in weeks. And knowing that T is weeks now helps me with this one. This is in thousands of headphones for X. And then my T is in weeks. So kind of just filling out the same chart at the top consistently. It helps make these problems a little less overwhelming. So we want to know how fast is the quantity demanded increasing. So I'm wondering, how is the demand increasing? So I must be looking for dx dt. X is the demand in thousands. It's not saying how is the price changing each week. It's asking how the demand is changing. So this is what I'm asked for. When the unit price per headphone is $16. So the current price right now, not how fast it's changing, what it is right now is $16. So P is 16. And the price, what we're going to do to it this time is we're actually going to drop it at a rate of 10 cents per headphone. So I'm given one of my rate of change. dp dt is 10 cents per headphone. So I'm dropping by $0.1. And since I'm dropping my price, I have a negative derivative. So negative 0.1 would be dropping 10 cents per week. So we're always solving for one of the derivatives as our answer. So we must be solving here. And it's an issue that I don't know X. So I need to solve for X just like we did in the last one we solved for N. So I'm going to take a second and bring this down here. I need to solve for X before I can even attempt to plug in all these values to the derivative. So I'm going to bring the X down here. I'm going to figure out what X is in the original function. So I have 100x squared plus 9p squared. And I know the price right now is $16 getting squared equals 3,904, taking that from above. Again, if you're missing a variable, you plug into the original function you're given, and for related rates, you're always solving for a derivative. So I need to figure out, what is this missing variable? What is the demand when the price is set at $16? So I plug in to the equation up here. So if I plug in, I have 100x squared, and I have 16 squared times 9. And I want to figure out what that value is and subtract it from that 3,904 on the other side. So if you plug in 16 squared plus 9, you get 2,304. And we're going to end up subtracting that from that 3,904 that was on the right in order to get X by itself. So 100x squared is going to equal 3,904 minus 2,304. So we get 1,600 over here. Next thing, to get X by itself, I'm going to divide both sides by 100. So X squared must be 16. And now I'm going to take plus or minus the square root of both sides. So X equals plus or minus the square root of 16. So the X value is either positive or negative 4. And I want to figure out which one it is, or if it could possibly be both. Well, we're talking about the number of things demanded. So the number of things demanded could only be a positive 4,000. It couldn't be a negative 4,000. So X must just be 4. You can't have that people demanded or bought negative 4,000 headphones. That doesn't make sense. So X is just 4 here, and that doesn't mean only 4 sets of headphones are demanded. We want to remember this is already in thousands. So now I can finally solve for my missing derivative. I can figure out what is dx dt. So if I take the derivative of my original function was 100 x squared plus 9p squared equals 3904. I'm going to take the derivative and plug in everything I know to solve for dx dt, the one thing that I don't. So derivative is going to be 200x dx dt plus 18p dp dt equals, can't forget about the derivative of the right side, derivative of 3904 is just 0, which is nice. So now I can plug in everything I know. 200, my x value, my current demand is 4, so that stands for 4,000, dx dt, plus 18 times my current price is set at $16, times dp dt. We're changing the price, we're dropping it, we're decreasing it by 10 cents, or 0.1 of a dollar. So if we plug in here, we have 800 dx dt, and then 18 times 16 times negative 0.1, that's negative 28.8 equals 0. So I'm going to add 28.8 to each side. So I have 800 dx dt equals 28.8. And now I get to divide both sides by 800 to get my final answer. I want to keep in mind the units on my answer are thousands of headphones per week. So I'm going to bring this way up here. dx dt equals 28.8 divided by 800. That's about 0.036. And my units on that are 1,000 headphones per week. But because I have to interpret this, we might just take a second and multiply that number by 1,000 so we can see how many 0.036 of 1,000 is. And we get 36 headphones per week. So our conclusion is going to be whether we're increasing or decreasing our demand when we drop our price. So as the price drops 10 cents, as the price drops 10 cents per week, the demand, our dx dt is the demand, changes. How? Is it increasing or decreasing? Well, we have a positive derivative for our answer, so the demand increases by 36 headphones per week, which makes sense. Headphones per week. Which makes sense. If you drop the price, your demand should go up. Our demand goes up 36 pairs of headphones when our price drops 10 cents.